So section 4.6, factoring quadratic polynomials. I'm going to teach you a technique, a method called A times C. And A times C is going to work with each of these different types. So this is your basic. And I'll be honest with you, when your coefficient of x squared, when your A, that's your A value because you have ax squared plus bx plus c. That's a quadratic expression. When your A value is 1, you should be able to mental math it. You should be able to mental math the factors. You should be able to break it up. It's when your A value is greater than 1 where you're going to use that technique of A times C. Now, we see in this one, this actually has a GCF, so we would factor out the 3, and then it would go back to having a coefficient of 1. But I don't think in 4.6 we have quadratic polynomials with values greater than 1. So we're going to do a bunch of them using A times C, and that's the beauty, is you'll be able to use A times C. It doesn't matter which one. But it really talks about it, and it's funny because it says, recall that multiplying two binomials often gives us a trinomial. So it's ironic that they do one where our A value is more than 1. We're typically going to work with factors when your A value is 1. So, but yes, we want to think, and it's important that we do, and I'll show you this. This is the best example, is you take the same binomials and you change the signs for each of them. So you keep the variables the same, you keep the numbers the same, but you change the signs. And since there are two signs, you can have 4 different outcomes. You can have both positive, well, let's do this, both of the signs negative, both of the signs negative, both of the signs positive, or you can have a situation where you have one is negative, one is positive, or one is positive, one is negative. So the way we categorize it is these are the same, the signs are the same. What do they produce? And these are when the signs are different. What do they produce? There are things that we will notice about the trinomials that these binomials produce. That's x squared minus 5x plus 6. This is x squared plus 5x plus 6. This is x squared plus x minus 6. This is x squared minus x minus 6. So we can look and see, gosh, what am I noticing? I'm noticing that the second sign, that this product is always positive. Well, it's always positive because you're multiplying -2 times -3. And this is +2 times +3. So when the signs are the same, this second sign will always be positive. And then this is actually an indicator of what those two signs are. You notice that they're both negative, and this is negative because this term is the sum of our outside and inside. That's our outside, which is -3x. This is my inside, which is -2x. So we see that the signs of those two terms, when we add them, will be the same. So it's going to make a bigger negative. We see that our outside is 3x, our inside is 2x, both positive numbers, +3x, +2x, so it makes a bigger positive. Now, you see where I'm going with this, I think you do. So notice that both of these terms, these final, because it's a product, is negative. Why is it negative? Because you're multiplying -2 times +3. The signs are going to be different. When signs are different, it's always going to be negative, or +2 and -3. So we know that when this second sign is negative, we know that the lasts, these signs must be different. And then we look and notice that our outside is +3, our inside is -2. So we ended up with more positives. So this tells me my bigger of the two is positive. This is -3x and this is +2x. And that means we had more negatives than positives. So the bigger product is going to be that. So we take advantage of that information when we work backwards. And that's where we should be able to look at this and go, okay, we have factors of 6 when added. Why is it adding? Because the signs are going to be the same. Factor of 6, 1 and 6, 2 and 3. The signs are going to be the same, and if they're the same, then they're going to just make a bigger, whatever that middle term is. They're going to make a bigger negative. So I know that both of these signs must be negative. And if I combine them, which ones multiply? Because if we multiply those two, we get +6. If we multiply those two, we get +6. But when we combine them, add them, we get negatives. Well, that's a product, and this is an addition. So what do those two that equal -7? It's this one. So x minus 1, x minus 6. Let's do. And those are my factors. That's factoring it. So I know that my signs are the same. I know they're both positive. And so I'm going to look for factors of 12. Factors of 12 are 1 and 12, 2 and 6, 3 and 4. My signs are the same and both are positive. Notice each of these multiplying to make +12. And when I combine them, sorry, this is +13, that's +8, this is +7. Which one equals my middle term? My middle term is that. So I get k plus 3, k plus 4. And we see that that makes 12. And then we do my outside and inside, makes 7k. So, ooh, whoop. No, not so much. So this is the way that you could do it when you have a coefficient or an a value of 1. So my signs are the same. They're both negative. Factors of 24, 1 and 24, 2 and 12, 3 and 8, 4 and 6. Signs are the same. Both are negative. We get -25, we get -14, we get -11, -10. Which one of those equals my middle value? -11. So I'm going to take these two and I'm going to write y minus 3, y minus 8. I just take these two values, -3 and -8. Signs, ooh, now what makes a negative as a product? The signs have to be different. And if they're different, we're going to combine them and we're going to get a leftover of +2. So factors of 3 are 1 and 3. And if I have more leftovers that are positive, then my bigger of these two numbers must be positive and the other has to be negative because they're going to be different. And I get +2, just like my middle term. So I'm going to get p minus 1, p plus 3, -1 and +3. Signs are the same. Both are positive. So factors of 6 are 1 and 6, 2 and 3. Signs are the same. Both are positive. 7 and 5. 5 is my middle term. So I'm going to get z plus 2, z plus 3. I'm just taking those two terms. Signs are different, and the bigger of the two factors are going to be negative. So I have 1 and 6, 2 and 3. So the bigger of the two, the signs are going to be different, meaning one's going to be positive, one's going to be negative. And the bigger, sorry, that says both, sorry, bigger is going to be negative. So of 2 and 3, 3 is bigger than 2. And my signs have to be different because when I multiply that, it has to equal negative 6. When I multiply, it has to be negative 6. And when I add them, it needs to equal my middle value. So why didn't I do negative 1 and positive 6? That multiplied makes negative 6. But if I combine them, I get positive 5. And I have a negative 5. So that's why we don't do that. That's why the negative has to go to the bigger. So negative 5, so we have a plus 1, a minus 6. Factors of 22 when subtracted, meaning my signs are different, and my bigger is going to be positive. 1 and 22, 2 and 11, 3 no, 4 no, 5 no, 6, 7, 8, 9, 10, and then we're back to 11. Signs are different. Bigger is positive. Signs are different. So 1 is positive, 1 is negative. That makes 21. That makes 9. 9 is my middle term. So we get t minus 2. And then we get t plus 11. So I'm just taking those factors and putting them in my binomial. Factors of 60 when subtracted, and the signs are different, and the bigger is negative. Factors of 60, 1 and 60, 2 and 30, 3 and 20, 4 and 15, 5 and 12, 6 and 10. I will tell you, when you do it this technique, you get really good at finding factor pairs. Signs are different and the bigger is negative, so I'm going to make all those numbers on the right side negative, all the numbers on the left side positive because they have to be opposite signs. That's going to give me negative 59. This is negative 28, negative 17, negative 11, negative 7, negative 4. Which one equals my middle? Negative 11. So I'm going to take those two terms, positive 4 and negative 15, and I'm going to say v plus 4, v minus 15. Super easy factoring. Factors of 5, when the signs are the same, we're going to add those factors, and they're both going to be positive. 1 and 5, 2, no, 3. Okay, those are them. Signs are the same, both, and 6. Oh, what do we notice? Not the middle term. It didn't equal my middle term. So this is what we call prime. It's unfactorable. And it's unfactorable, meaning it doesn't produce whole number factors. We have another technique to use a little bit later called the quadratic formula. And I'll teach you that a little bit later. But this one is our first unfactorable using this technique. This technique. What technique? Well, that's sort of like an algorithm. I will teach you A times C. It's coming. But this is the technique. Look, you really should be able to look at this and be able to factor it. Factors of 36. When the signs are different, you're going to subtract the factor pairs to get positive 5. So 1 and 36, 2 and 18, 3 and 12, 4 and 9, 5 no, 6 and 6. Signs are different. So, and the bigger is positive. Bigger is positive. Remember, when we write our factor pairs like this, the bigger of the two numbers will always be on the right side. And we need our signs to be different. That's 35, that's 16, 9, 5, 0. Which one equals 5? These two. So you get s minus 4, s plus 9. Super easy way of learning how to factor. 36 again, but this time the signs are the same. We're going to add those factor pairs, and they're both negative. So 1 and 36, 2 and 18, 3 and 12, 4 and 9, 6 and 6. Signs are the same, both are negative. Negative 12, negative 13, negative 15, negative 20, negative 37. 15, so negative 3 and negative 12. H minus 3, H minus 12. Factors of 8 when subtracted. My signs are going to be different, which makes me subtract the 2, and the bigger is positive. 1 and 8, 2 and 4. Signs are different. Bigger's positive. That's going to give me 7 and 2. Neither is equal to my middle. So this is prime, or sometimes they say unfactorable. Oh, if the polynomial's prime, say so. Yeah, okay, good. Glad I'm following directions. All right. Okay, we notice what happened. We have an a value that is greater than 1. So I'm going to teach you a times c. Remember, this equation is this. So this is my a value, this is my c. I say a times c. A is 8 in this case, c is 1, and we get 8. We're going to go through the same process. Factors of 8, 1 and 8, 2 and 4. Signs are the same, meaning we're going to be adding, and they're both positive. That's 9, sorry, that's 6. So this equals my middle. We're going to change it up a little bit here. That's my middle, but because the coefficient, because a is more than 8, we have to split this. We're going to split this middle term, because think about what made 6, 2 and 4. Before we broke it into two binomials. But we're going to split this 3 terms into 4 terms. My au squared is just going to come down. My 1 is going to come down. But I'm going to split this 6u into these. And I'm going to make it 2u plus 4u. What's 2u plus 4u? 6u. So I didn't change anything. All I did was just break it down into, I changed my middle term to 4 terms. Because remember, if we go back to multiplying binomials, where did I do this? Remember, this is the sum of the outside and inside. That was negative 3x and negative 2x. Ho-ho! 3 and 2, factors of 6. Hello! Yeah, so all I'm doing is I've created those middle 2 terms. So I created the middle 2 terms, my outside and inside. Well, why did I do that? Well, because we are going to use that. We have 4 terms, and what's the technique we use? 4 terms, factor by grouping. Factor by grouping, meaning we look for the GCF between these 2 terms and the GCF of these 2 terms. So 8u and 2u, I'm going to factor out a 2u. That leaves you 4u plus 1. When I have 4u plus 1, I'm going to, oh wow, they start off with a tricky one. I'm going to factor out a 1. There's no GCF, so when you don't have a common, what's your greatest common factor is 1. If I take a 1 from 4u, you get 4u. If I take a 1 from 1, and we did it correctly. How do I know I did it correctly? Because these must be the same. That's how you know you did it right. So I'm going to pull out the 4u plus 1 because that's a common factor. And if we pull those out, we're left with, if I remove the 4u plus 1, you're left with 2u plus 1. So that leaves me with 2u plus 1. And we just factored when a trinomial when a is greater than 1. Here's another one. So a is greater than 1, so we're going to try a times c. A is 12, c is 1, which equals 12. Factors of 12 are 1 and 12, 2 and 6, 3 and 4. My signs are different. That means we're going to subtract, and the bigger is negative. So my bigger of the two are negative. That means the smaller are positives. That gives me negative 11, negative 4, negative 1. So my middle term is 1, negative 1 there. So I'm going to take these two and I'm going to split my middle term up. So we bring this down, 12y squared. Now I'm going to use my middle terms. This is my new middles, plus 3y minus 4y, because what's positive 3y minus 4y? That equals negative 1y. And then we bring down my negative 1. And now we're going to factor by grouping. Grab these two, grab these two. We did it. They definitely are challenging us. So let's look. What's the greatest common factor? 3y. You get 4y plus 1. Notice my first term is negative. I must factor out a negative. And then there's no factor, so I'm going to factor out a negative 1. And that gives me 4y minus 1. Oh, plus 1. Nope. Minus 1. Ooh, ooh, ooh. What did I do? What? Oh, duh. That's a minus. Sorry. Sorry. That was a minus 1. I made a mistake. I made a mistake. And I knew because these weren't going to be the same if I factored out that negative from it. So I know I did it correctly because these have to be the same. They must be the same. So I pull that common factor. I turned it on for that very reason. And let me message. Well, let's do this. Stop. Thank you. Please bear with me. I'm making a movie. I'll call you when I'm done. Yes, I knew. I turned on the ringer because I knew that was going to happen. All right, we factor out the 4y plus 1. And what does that leave us with? That leaves us with 3y minus 1. That's my other binomial. That's a horrible 3y minus 1. And that's how we factor. A little bit more time consuming. Yes, finally, number 15. So a is greater than 1, so we're going to use the a times c technique. 2 times 3. I know that says negative, and we'll use the negative later, but right now we just need to find factors of 6. Factors of 6 are 1 and 6, 2 and 3. The signs are different. We're going to subtract the two factors, and the bigger is positive. So bigger of the two, signs have to be different. That's 5, that's 1. That's equal to my middle. All right, there's a 1, a positive 1. Or there's a 1, sorry, it doesn't have to worry about positive and negative. Well, yes, we do. Positive 1. So we bring down the 2p squared. These are going to be my new two middles, minus 2p plus 3p, and then we bring down the negative 3. So that comes down, this comes down, and we do a new middle. We're going to factor by grouping. We can factor out a 2p. That gives us p minus 1. We're going to factor out a 3. That leaves me with p minus 1. So p minus 1, 2p plus 3. Yep, that fast, that easy. You will see that in high school, some teachers will teach you some box method. They'll teach you some other crazy stuff. I will tell you, in the 32 years and 32 years, this is the best method. Sounds great. Thanks. Apparently we're having chicken nuggets and Caesar salad. A times C, 3 times negative 10. I keep doing the negative. You can include it or not. It's okay. I'm not adverse to it. Equals 30 factors of 30, or 1 and 30, 2 and 15, 3 and 10, 4, no, 5, yes, and 6. And now we're around the horn. We've got all of our factor pairs. The signs are different. And we're going to subtract the 2 factor pairs. And the bigger is positive. Positive, 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 negative, 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 negative. 29, 13, 7, 1. Oh, 1 again. One of these times it won't be the bottom factor pair, but that's equal to my middle. It's okay, it doesn't matter. Still going through, you're getting comfortable. 3r squared, I'm going to break my middle into minus 5r plus 6r minus 10. Let's factor by grouping, because we have 4 terms. Whenever we see 4 terms, we always think factor by grouping. We can only take an r out of there. That leaves us with 3r minus 5. We can take out a 2 from there. That leaves us 3r minus 5. Did we do it correct? Yep, because these are identical. They must be identical. Since they are identical, we can pull it out and factor it from those 2, and you're left with r plus 2. And there's something beautiful about that. Awesome. Great work. A times C, 6 times 2 is 12, 1 and 12, 2 and 6, 3 and 4. Signs are different. The bigger is positive. This gives us 11, 4, 1. Come on, let's get different. So these are going to be my middles. 6n squared minus 3n plus 4n minus 2. Mr. Mac, how did you know that these were n's and not n squares? Well, remember, when we combine them, it needs to equal that variable. So intuitively, we know that it must be an n. So we'll take out a 3n from those first 2. That leaves me with 2n minus 1. We'll take out a 2 from those second pair, and you get 2n minus 1. I did it right. 2n minus 1, 3n plus 2. And if we multiplied, if we FOILed it, we'd get this. That's how you can check your answers. Check your work. Multiply those 2 binomials out. Do you get your starting trinomial? Oh, finally. Let's go. Our middle is not 1. All right, a times c, 4 times 6. A times c, 4 times 6 equals 24. 1 and 24, 2 and 12, 3 and 8, 4 and 6. Signs are the same, and they're both negative. Negative, 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 negative 10, negative 11, negative 14, negative 25. This equals my middle term, negative 11. 4w squared minus 3w minus 8w plus 6. Let's do 4w minus 3w. Let's do negative 8w plus 6. 4w squared minus 3w. We can only factor out a w. That leaves us with 4w minus 3. My first term is negative. I need to see that. That means I need to factor out a negative 2. which leaves me with 4w minus 3. And we can check that. Does that equal negative 8w? Does that equal positive 6? Yes, it does. Always can check. Whoa. You can always check by redoing the work. Now we have 4w minus 3, so we'll pull that out, and that leaves us with w minus 2. Your teacher is going to look at you and go, oh my goodness, how did you do that so fast? And you're going to go a times c. Promise you on there. All right, be careful here. We should always look to see, is there a common factor? In all the problems that we had, no common factor. 4, 11, no. 6, 1, no. 3, 10, no. 2 and 3, no. No common factor. So there was no common factor, much like that we started with in 4, 5. So there is a common factor here. We can factor out a 2. If we factor out a 2, we get t squared minus 2t minus 35. And now we go through the process, and we're only looking at the trinomial. We're just factoring this. We're doing a times c with this. Now, we don't have to do a times c because a is equal to 1. So we would be able to do, we're subtracting factors of 35 when subtracted. Signs are different, and bigger is negative. So 1 and 35, 2 no, 3 no, 4 no, 5 and 7. That's it. Signs are different. Bigger is negative, positive. We get negative 34. We get negative 2. That equals so because a is 1, we can just take those two factors. We don't have to do factor by grouping. So t plus 5, t minus 7, and I'm done. Just don't forget about that factor, that first term, number 2 that you factored out. Now, right, why didn't I make this my middles? I could have done that. I could have turned t squared plus 5t minus 7t minus 35. I could have done the a times c method, because you'd factor out a t, you get t plus 5. You factor out a negative 7, you get t plus 5. And you still get t plus 5, t minus 7. And then you'd have to remember your 2 out there. So it's just when a is 1, you can take those factor pairs, and those are your binomial terms. 3, 9, and 30, so we can factor out a 3 first. You have x squared plus 3x minus 10. All right, my a's, factors of 10, 1 and 10, 2 and 5, signs are different. Bigger is positive. 9, 3, that's my middle term. So 3 times x minus 2, x plus 5. And again, if your teacher sees how fast you do this, they are going to be blown away. And you should be able to do all of this by the end of 8th grade. You want to show proficiency in Algebra 1, you have to be able to do this. I'm telling you, I know. You always tell me. Yep. We can factor out a 2k. That leaves us with k squared minus k minus 56. Now, a is 1, so we can just take factors of 56, 1 and 56, 2 and 28, 3 no, 4 yes, 4 and 16, 14, 4 and 14, 5 no, 6, no, 7 yes, 7 and 8, and that's it. Signs are different, and the bigger is negative, 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 negative. Signs are different. Negative 55, negative 26, negative 10, negative 1. Negative 1 is my middle coefficient, so we get 2k times k plus 7, k minus 8. 5, 25, 30. Yep, we can factor out a 5z. That's z squared minus 5z plus 6. Factors of 6 when added equal 5. Signs are the same. Both are negative. 1 and 6, 2 and 3. When added, when they're the same, you add, oh, both negative, sorry. Negative 5, negative 7, negative 5. So we get 5z times the quantity z minus 2, z minus 3. Not many more. 27, 48, 12, 3, 9, yeah, 3, 3, and ooh, make sure x to the fourth, x to the third, x to the second. So definitely make sure that you are in standard form also. We'll get, right now 1 is standard form, 2 is there a common factor, 3 technically is it a special case, is it a binomial square, is it a difference of square, 4 actually is my a times c. And those are going to shift down one more. Standard 4 is going to be 2, common factor is going to be 3, special case is going to be 4, a times c is going to be 5, because we'll do something different a little bit. We'll add one more initial step. But we can do 3x squared. So that gives me 9x squared plus 16x, 3 to 18, yeah, minus 4. Oh. And speaking of special cases, do you remember binomial square? Oh, nope, sorry. Binomial square has to have second needs to be positive, so that's not it. So we're going to do a times c. We're going to take the a and the c value, 9 times 4, 36. Factors of 36 are 1 and 36, 2 and 18, 3 and 12, 4 and 9, 6 and 6. Signs are going to be different. We're going to subtract our factor pairs. And the bigger is positive. So positive, signs are different. 35, 16, 9, 5, 0. 16, that's good. That was a unique one. We haven't done that. 3x squared. Since this is a times c, we're going to split our middle. So we just pull down 9x squared minus 2x plus 18x minus 4. Now we're going to factor by grouping. We're going to group the first two, group the second two. We're going to look for a GCF of those. So 9x squared, we can just take out an x. You get 9x minus 2. 18x minus 4, we can take out a 2. That gives us 9x minus 2. Those were the same, so we knew we did it right. 3x squared. We're going to pull out that 9x minus 2, and we're left with x plus 2. There's our x plus 2. Yes. Woo! We keep getting harder, more challenging. All right. We are going to see if is there a common factor. 4, 6, 4, 4x squared. That gives us 9x squared plus 11x plus 6 plus 6. A times c. A is 9, c is 6. That gives us 54. Factors of 54 are 1 and 54. 2 and 27. 3, yes. 3 and 1, 18. 4, no. 5, no. 6, yes. 6 and 9, hello. And that's it. Signs are the same. We're going to add our factor pairs, and they're both positive. Plus, 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 plus. That's going to be 15. That's going to be 21. That's going to be 29. That's going to be 55. Did I do it right? Let's make sure I did it right. 36, 44, 24. 9 times 6 is 54. We're going to add to get 11. And we notice that that's as far as we can go. So this is, so we could factor. We wouldn't call it prime because we were able to factor something out. But that would be our answer. Let's go! Yeah, that was a good last one. We definitely got tested on that on the last couple. Those are fun. This is section 4.6, and let's just make sure 4.6. Where are you? 4.6. Chapter 4.6. That's 5. There's 4. 4, 5, 4, 6, number 24. Let's see, number 24. 24 additional answers in the back. I hate when they do that. I hate when books do that. Just give me, just tell me, make space or something already. Chapter 2, Chapter 2, Chapter 5, Chapter 4, oh, where are you? Chapter 3, oh, Chapter 4 must, answer keys must be, probably put that somewhere also. You extra, well, I thought I maybe pulled that page out, 54. I know this video should be over by now. It should, but it's not because Mr. Mac is being a little 143, yeah, those pages are missing. Where's 146? Where's the, here we go, Chapter 4. Number 24, 4x squared times the quantity 9x squared plus 11x plus 6. Mr. Mac out.